first reason for proof that we're going to be adding to our repertoire, which is a little bit of an obvious one. All right angles are congruent. Well, we know that all right angles are congruent. That's just kind of as a no-brainer. But this one comes into play nicely when you start talking about right angles and you need to prove congruency. You can just say, well, they're congruent because all right angles are congruent.
Sweet.
Okay? So that one's pretty nice and easy. Now, in the textbook, if you guys go back to look in the textbook for these next two, they have them written out as theorems, but I prefer you writing out the actual if-then part because I think it helps you to comprehend what it is it's talking about. So the first one's called the supplement congruent theorem, and let me just quickly show you what this looks like before we write it down. If I have, let's say, angle 1 and angle 2, and let's say that those are supplementary. Do they look pretty supplementary?
For the most part.
For the most part, sure. And let's say I have angle 3. So if angle 1 is congruent to angle 3, would it be true that angle 3 and angle 2 would also be supplementary?
Yeah.
Yes. If 1 and 2 are supplementary, and 1 and 3 are congruent, then 3 and 2 would also be supplementary. So that's what this number 2 is going to say. If two angles are supplementary, feel free to abbreviate these words however you want, to the same angle, then they are congruent. Okay. So the same thing's going to apply with complementary angles. Let's say I have angle 1 and angle 2, and then I have angle 3. So if angle 1 and angle 2 are complementary, so if they're complementary, and angle 2 and angle 3 are complementary, whoops, I don't even know what I was trying to spell out there, complementary, what would be the other congruent angles? So if angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, where are your congruent angles?
1 and 3.
1 and 3, perfect. So that's our third one. If you just want to put ditto marks and then just put the word complementary, feel free. It's the same sentence as what you just wrote, just the word complementary instead. If two angles are complementary to the same angle, then they are congruent. Okay, in the book they call it the complementary congruent theorem. Okay, so 2 and 3 in this class, we're not going to be using those that much. So I wouldn't rate them high on the totem pole of all the reasons for proofs that we have.
Why are they number 2 and 3 then? Isn't that pretty high up there?
It's just the order that they are presented in the textbook. I could have made them bullets. Should I make it bullets for future reference instead of numbers?
So the one most important. No
Roman numerals. All right, and then the last one that we're going to be looking at, well, I guess we have 5, right? So our fourth one talks about linear pairs. So if two angles form a linear pair, then they are supplementary. I feel like we might have written this one before. So if two angles form a linear pair, then they are supplementary. So we've got right angles, supplementary, complementary, linear pair. And the last thing we have to cover is vertical angles. What's true about vertical angles?
Straight up.
They're straight straight up? Not necessarily. There can be congruent. So if we remember what vertical angles are, what would be the vertical angle of 4? 2. What's the vertical angle of 1? 3. And they're going to be the same in measure, which means they're going to be congruent. So our last statement is, if angles are vertical angles, then they are congruent. Then they are congruent.
Honestly, like, I don't even know what that means. Like that, the words that are like.
So if angles are vertical.
Number 2, like on here, just confuses me. If 2 angles are supplementary, the same angle when they're congruent.
All right, so I can restate that using numbers, which might help. Do you have this one written down though? All right, so let's think about these using actual numbers. That might help. I'm just going to jump back to number 1. Number 1. Do we get number 1? All right angles are congruent?
Yeah.
Okay, so number 2. If I have, let's say, an angle that is 80 degrees, I'm going to call this angle A, and then I have an angle B that would be 180 degrees. Is A and B supplementary right now?
Mm-hmm.
Yes. If I have angle C, and angle B and C have to also be supplementary, what would C's measure have to be? 80 degrees. So is it true that the 2 angles that are both supplementary to the same angle are congruent?
Yeah.
Yes.
That's what number 2 is saying. Okay. Number 3 is the same thing, just complementary. So if I had angle A was 30 degrees and angle B is 60 degrees, those are complementary. If B and C have to both be complementary, then C would have to be 30, and then that means that the 2 angles that are complementary to the same angle would have to be congruent. Okay. Number 4, visually, if 2 angles form a linear pair, well, that means they make a straight line, then they have to add up to 180, right? They have to be supplementary. So if 2 angles form a linear pair, then they are supplementary. Right? So if this was 100 degrees and this was 80 degrees, they make a straight line, a straight angle, and they're supplementary. And then the last one, if angles are vertical angles, then they are congruent. Well, if these are vertical angles, and that's 43 degrees, then that has to be 43 degrees, because they're vertical angles. They're going to be the same. Okay? Does that help? All right, so now we're going to do some solving. It's going to be a lot of what your homework is going to be based on. It's kind of a kickback to Chapter 1 when we were doing this stuff.
Section 5?
Was it Section 5 in Chapter 1? Maybe? I don't know.
I think so.
All right, how would I solve for x here?
I know this one.
Subtract 135 from 180.
Yeah, why are we doing that?
Because it's...
So, reason for proof. If 2 angles form a linear pair...
Whoa. What?
Wait,
Is that...
This is for your reason for proof.
are we putting this on the proof line?
Well, you guys, for your notes, if you want to just put the number that it matches up with, do you guys just want to do that?
Yeah, sure.
All right, so for your proof line, which number describes what's happening here? Well, we have a set of linear pairs,
4.
and it's linear pair means that they're going to be supplementary. So this is number 4. You want to write above, so when you look back at it, you know what you're talking about. So to get that, x plus 135 equals 180. So it would be what? 45? 45. Right?
It's okay.
Yeah, 45.
Okay. All right, for B, what do we got?
X equals 146.
X equals 146. Why do we know x equals 146? If angles are vertical, then they are congruent. Which number was that?
5.
Number 5. On your homework, you're going to have to actually write out the if-then statements. Don't just write number 5. It's really not number 5. It's just number 5 on our list. And then for the third one, what about this one?
Subtract 27 from 90.
Yeah. 90 minus 27, which gets us to,
Number 3.
63?
yeah, 63. Yeah, we're talking about complementary, so number 3. Okay. All right, now we're going to get to the really fun ones. Here we go. Do you remember these from chapter 1? We're going to solve for both x and y's. All right, let's start with x's first. Find your x's in these expressions. Do they make a linear pair or do they make vertical angles? Vertical angles. So if two angles are vertical, then they are congruent. So how am I going to solve for x?
4x plus 26 equals 6.
Good. 4x plus 26 is equal to 6x. Subtract your 4x from both sides using that subtraction property of equality. 26 is equal to 2x.
And 26 is 13.
13. Division of property gets us x equals 13. How are we going to solve for y?
Same way, probably.
6y plus 8 equals 7y minus 12.
Good. 6y plus 8 equals 7y minus 12. Using the subtraction property of equality, subtract 6y from both sides. 8 is equal to y minus 12 plus 12. So y is equal to 20. Which reason for proof would justify what we did here?
5.
The last one, yep, number 5. If two angles are vertical, then they are congruent. Everybody got that? Okay, so now let's look at the next one. Now look where your x's are. Are they vertical anymore?
No.
Nope, they make a...
Right angle.
No,
No, it's supplementary.
Why do we know they're supplementary?
Because they add up to 180.
Because they are
Straight line.
Straight.
the linear pair, right? So if two angles are a linear pair, which number was that one?
4.
Then they are supplementary. So what's going to be my equation to solve for x?
7x plus 4 equals 4x.
Nope,
plus
not equal. We said they're supplementary.
Plus 22. I mean,
So we're going to add them together and equal it to 180. Good. Okay, luckily, you're not going to have to do a formal proof with these, but you would have to set this up, and then you would say, if we did a formal proof, if two angles are a linear pair, then they are supplementary. Then we would do a simplify. So 7x plus 4x is 11x. 4 minus 22 is
negative 18.
Yes, thank you. Catching that. I almost put positive 18. Negative 18 equals 180.
Subtract the 18, or
Add the 18 to both sides. Addition property of equality. So 198. Division property. Divide by 11. So x is equal to... 11 goes into 19 one time. Remainder of 8. So 18.
18.
Okay. How are we going to get the y?
Same way.
Same way we did that. So 3y.
Plus 11 plus 10y.
Good, equals 180. Do a simplify by combining like terms. 13y plus 11 equals 180. 180 minus 11. So 180 minus 10 is 170. Take away 1, 169. Divide by 13. And we get 13. So our reason for proof here would be which statement?
4.
The linear pair one. Which one's the linear pair one? 4. If two angles are a linear pair,
Then
then they are supplementary. Good. All right, let's do it. Ready? Formal proof. Formal proof. On the back. Give you
No.
lots of space.
No.
All right. Why? Why, you ask? Set it up.
No, thank you.
Statements on the left. reasons on the left, right. You're gonna love proofs by mid-year.
No.
Number 1, angle QRS and angle PSR are supplementary. If I can spell supplementary right, that'd be great. Given. All right, now let's think about this. Let's look at this actual diagram and wrap our brains around it. So QRS is this angle right here. Angle PSR is right here, is this angle right here. So we're saying that these two angles are supplementary, which means that they both are going to add up to 180, right?
Right.
All right, so what are we trying to prove? I got a little dark.
That they are supplementary.
Look at the prove line. I'm trying to prove what?
Angle QRL is congruent to angle PSR.
All right, so angle QRL is over here, and angle PSR is right here. Interesting, huh? All right, so look at our proof line. Do I have PSR already mentioned in my proof?
Yeah.
Yes.
Do I have QRL already mentioned in my proof?
No.
Not yet, but we want to get it there. How can I incorporate it into my proof?
Angle addition and postulate.
That's a good thought, but we can't do that here because we don't really have a full total angle. Or could we do angle addition? I wouldn't go angle addition.
Substitution.
No. Let's think about the stuff that we wrote on the front of our page. Do I have vertical angles that I would want to use? Like, would I want the vertical of this or the vertical of this? No, because that's not part of my proof. So let's not think vertical. I don't have right angles, so I can't use a right angle. Do I have a linear pair someplace?
No.
Is this a linear pair with another angle?
The one right across from it.
That
No,
one, right?
Yeah.
Or this one. I mean, we could do this one, but that's nowhere involved in my proof. So could I say that angle LRQ is a linear pair with angle QRS?
Yeah.
Sure, why not? The diagram's showing it to me. So, line 2. Angle LRQ and angle QRS are a linear pair. What do you think we're going to write on the other side? Well, it's not substitution. We didn't substitute something in place of something. Not a simplify. I like that you're guessing, though.
If two angles form a linear pair, then they are.
Not yet. That's going to be next line. We're almost there. If something is just on a diagram, nope. Nope, it's nothing.
Okay.
If something is just pulled from a diagram, like this is a linear pair for that, and we're just going to say given from diagram. Because I pulled that information from the diagram. No, it's not. Okay, so because they are a linear pair, what's true about those two angles? So well, before that, they are supplementary. So angle LQR and angle QRS are supplementary. What's my if then that I'm going to say there? Oops. If two angles which number are we working off of from the front?
4.
So if two angles
Form a linear pair.
Form-
Then they are supplementary.
there we go. Linear pair. Then they are supplementary. Ooh, okay.
You have way too excited about this.
Look at 1 and 3. What do they both have in common?
L, QRS.
They both are supplementary to QRS.
So they're congruent.
Because of what statement on the front did we write?
I don't know.
If two angles are supplementary to the same angle, then they are congruent.
Yeah. And I'm just going to flip around my letters. I should have put this as QRL to stay consistent with what the proof is. So now I'm going to say angle QRL is congruent to angle PSR because,
Can we just write the letter? I mean,
no, if two angles are, you can put sup for supplementary if you want, to the same angle, then congruent, I'll let you shorten it up like that. And we got it. Done and done.
Do you just like always liked math? Or
I do not always like math, to be honest with you.
really?
It wasn't until Algebra 2 in high school where